So to start, I need to tell you a little bit about myself and my background and why I'm here with you today at all. My name is Laura Edelson. I'm a computer scientist. I'm a professor of computer science at Northeastern University. And so you may be asking, what am I doing here talking to you about competition at an antitrust conference? And the answer is because I also served as the chief technologist in the Antitrust division in 2022 and 2023. And while I was there, mostly working on a whole bunch of tech cases and helping the Antitrust division think about what competition policy might mean, in technology sectors, I noticed this thing. I noticed that when I was learning about all these, seminal tech cases, they all lined up roughly perfectly with these periods of just incredible flourishing of technical innovation that I knew about, as a computer scientist. And I thought that was sort of a really interesting and odd phenomenon. And so I think after a lot of thinking about this and a lot of historical research, I've roughly speaking come up with what I think is an answer to this historical pattern of understanding why this has happened time and time again. And so today I'm going to be talking to you about why I think this pattern occurs. We're going to talk about a couple of case studies in which I think it's very easy to see this pattern. And then we're going to talk a little bit about what all this means in today's landscape. And we're going to do that through the lens of Google and large language models. Okay, so let's start with that tech monopolist dilemma, which is this pair of competing incentives toward innovation on one hand and stasis on the other. So what do I mean? So let's just talk a little bit about technology markets writ large. So first of all, if you're in a technology market, you are in the market of creating and refining new general purpose technologies. General purpose technologies tend to be disruptive to existing businesses. It's just a thing about technology markets. Additionally, technology companies' comparative advantage typically lies in expertise. That expertise may be protected by patents, but it is held by employees. And lastly, technology companies, they must continually invest in R&D just to keep up with their competitors. So this isn't like other kinds of markets where you can get really good at making your product and then make the same product for 100 years. You get really good at making your product, and that buys you enough time to do the R&D to come up with the next version of the product. It's just a thing about technology markets. Okay, so if this is sort of the nature of technology markets, okay, well, we know that you have this drive toward innovation. That's a given. But you also have a drive towards stasis, because if you're a monopolist, you believe that you have captured all of the value a market contains. And what you really should be doing is taking actions to maintain the status quo of that market, because that's optimal for you. You've captured the market. Okay. So what do these two incentives drive you to do? Well, they drive you to do a pair of kind of interesting things. First, you are absolutely driven to build that new disruptive technology. You're going to have all of that expertise around, and you're going to have to engage in a lot of R&D spending. You're going to wind up with new disruptive technology. It's going to happen. But new disruptive technology is going to be a threat to the status quo that, as we've established, is great for you. And all I've done so far is I've just sort of reformulated the Schumpeter-Arrow debate. So what? Well, the so what is when we look at how technology firms have historically responded to this dilemma, it's quite instructive. what they do is they absolutely engage in that innovation. Again, that innovation is not something that they can avoid. However, what they tend to do is they will always tie that new innovation to existing products and frameworks. Well, so what? That sounds great, right? We're going to get that new innovation. The monopolist will be able to maintain their perch, so that sounds great for them. But it actually does create a problem for consumers and and countries, which is that this pattern of captured innovation, of I'm going to innovate, but then I'm only going to release it through my existing product or service, is it tends to underutilize new innovation. And so what we actually wind up with is an awful lot of innovation that just gets left on the shelf. And so again, when we look at these historical cases, which we will get to, I promise, what we find is that when enforcement works in those cases, it works by unblocking that dam. It works by unleashing that captured innovation that exists, that's sitting on a shelf, but is just being underutilized. Okay, do you believe me? We'll see. Okay, so let's get into our first case study. So we're going to talk about IBM. There's a whole bunch of IBM antitrust cases. We're going to be talking about this one in the 60s. So a little bit of background on the sort of the history of the general purpose computing industry. So throughout the 1950s, there are more and more computers being purchased and deployed by companies. However, hardware and software are always bundled. They are, we are starting to get things that could be, they're Turing complete, they could be general purpose computers, but they don't have some of the very basic building blocks we know today. They tend to be single purpose machines like your toaster oven. And really importantly, if I write a program for one computer, it cannot run on any other computer. And a computer typically can only do the one thing it was ordered to do. It's not general purpose yet. In the early 60s, this began to change. And more, companies didn't want a machine that would calculate payroll. They were starting to want to do more complex tasks. Some of the early applications here were things like econometric models. But eventually, customers wanted computation itself. They didn't want the output, something a computer would do. They wanted the computer. And computation is just an inherently a general purpose task. And this is what companies wanted because they wanted to supply their own programs and to be able to adapt them and iterate them over time. And by this point, computers were all Turing complete. And so at least theoretically, a task performed on one computer could be executed by any other computer. But it was going to take a few more software steps to get us there. And this was the thing that really got us here. Genuinely one of the most transformational products of all time, the IBM Systems 360. The amount of innovations that all happened at the same time to make this product work, it's truly remarkable. Just to think about, this was the first time we had system-independent architecture. This was the first time we had a computer with emulators that would allow it to emulate how another computer worked and how it processed instructions. This is the first time we get an operating system, a true operating system that we would recognize today that could control access to system resources. But it was still only sold as a task-specific tool. It was sold with all the software that you might want to do whatever task you had bundled in with it. We have here a general purpose technology that has been tied to an existing product. Okay, but this was without a doubt a disruptive innovation, and it yielded massive benefits for IBM because it was a general purpose tool, a general purpose compute device. This was a massive cost savings for IBM because they didn't have to make many different lines of computers to meet their different customers' needs. They can make one. This hugely reduced their maintenance costs. It increased their flexibility. It increased the, just the last mile configurability, and therefore allowed customers to purchase upgrades. And during this period of time between 1964 and 1969, IBM's net earnings roughly doubled. So this sounds great, right? You doubled your revenues. IBM was massively profitable. They had a product line that was wildly successful and delivering a tremendous amount of value. But inside IBM, this was perceived as something that they could never and should never do again. Thomas Watson Jr. is quoted as saying, "There is no question we cannot go through another announcement like 360 where we obsolete virtually our entire installed revenue base at one time and where we commit a very substantial portion of our total production to a new technology." And they never did. So, unblocking the dam, how did that happen? Well, it's really quite simple. The DOJ launched an investigation into the tying of that general purpose technology, general purpose compute, with software. And so in response to that threat, IBM announced that they were unbundling software and services from hardware in an attempt to head off DOJ antitrust prosecution. And we know that this was in direct response to the threat of prosecution from internal reports. This unfortunately did not stop the DOJ from filing that antitrust suit. They were followed shortly by several private antitrust suits. But by the time the cases were filed, IBM's internal view was the way that they were going to win those cases was by following through on unbundling. And unbundling from the market perspective was tremendously successful. By 1980, the revenue of software companies had grown explosively from effectively zero to billions of dollars. And what I find particularly interesting is IBM was not replaced with one or two or three monoliths. There were thousands of firms at a range of sizes doing a wide range of different tasks. And all of this came from virtually nothing in about a decade. So here we see the global sales of U.S. product firms and the tremendous growth that happened through the 1970s continued. That was not the end of the story. Okay, so it happened once. I don't know. Maybe it was a one-off. Who knows? Let's take a look at AT&T. Okay, so I guess again we have to say we are talking about the antitrust actions that culminated in the '84 breakup. Again, there were multiple antitrust cases over the years, but we're going to focus on this one. So we're shifting gears a bit from computing to signal transmission. And so as a little bit of setup, we should just talk a little bit about the state of the U.S. signal transmission network prior to the 70s and 80s. So the U.S. telephone system was effectively a government-enforced monopoly until 1984. Only AT&T was allowed to offer long distance until about the mid-1970s. There was some other signal transmission capacity. It was mostly telegraph lines that were owned by the company that became Sprint. But they're really, pretty much, it was the Bell system. Non-AT&T owned equipment could not be acoustically connected until 1968 as a result of the Carter phone decision, and non-AT&T owned equipment even then couldn't be electronically connected until 1978 as a result of the computer to rulemaking. So what did all that mean? So AT&T was like IBM, incredibly innovative in their development of signal transmission technology. AT&T built the first coaxial cable between New York and Philadelphia in 1936, and then basically never built any more again. They built the first commercial microwave relay line from New York to Boston, never built any more, and that was in 1947. And then in 1970, they built the laser, which is how you transmit signal over fiber optic cable. In the same year, Corning invented the glass fiber optic cable itself. And then AT&T never built any commercial transmission lines until after the breakup. But they were inventing all this stuff. I'm not even going to talk about their invention of cellular technology, satellites, a tremendous number of things. We have a whole bunch of general purpose technology, signal transmission. Now let's talk about data transmission, the other very important piece of this puzzle. Data transmission is also very old. The photoelectric fax was invented in 1881. Modems, that of the kind that we continue to use today for signal transmission, they were invented by Bell Labs in 1958 for the SAGE air defense program. The international G2 standard for faxes was agreed in 1976. But we didn't get any of those things then, despite the fact that we also, I just told you, during, at these very early dates, we knew how to make much higher bandwidth signal transmission. And we had the devices. You have another general purpose technology. However, AT&T only wanted to deploy these technologies tied to their existing service. And their existing service was phone calls, voice signal transmission. So just to recall, no other company was allowed to sell long distance telephone service in the United States until the 1970s. But even after this was legally allowed, AT&T pretty seriously refused to allow interconnection with the existing Bell system. And this lack of willingness to allow interconnection was the basis of the DOJ antitrust suit. But they pretty effectively forestalled any competitor from entering the market until 1980. And not only did they prevent other competitors from selling long-distance service, they also blocked other companies from selling any kind of equipment that electronically connected to the network until 1975. And because of the rulemaking process, practically speaking, the ability to sell non-AT&T equipment, roughly speaking, didn't exist until 1980. Who's old enough to remember this? Anybody? A few people? I see a couple hands. This is what's known as an acoustic coupler. So in the early days of signal transmission, if you wanted to connect your computer to your university server or to use email or anything like this, it was a little cradle that would be next to your computer, and you would pick up your phone and you would put that your phone handset on this little cradle, and you'd hear a bunch of like beeps and boops, and that is how your computer would talk to a server somewhere. It never needed to do this. This was only ever a regulatory necessity. This was not a technical necessity, and in fact, it was a technical hamstring. This would have been faster, better, cheaper if they could have just used an electronic connection, as AT&T did. Okay, so we had our general purpose technology. We saw how AT&T was only allowing it to be used in service of their existing product and service. And we saw the sort of hamstringing that was going on when anyone tried to do anything else. And we see this series of enforcement actions that finally led to the breakup of AT&T. And this is what really unblocked the dam. After the AT&T breakup, the price of a phone call fell dramatically. The number of fax machines sold in the United States skyrocketed. Modem sales skyrocketed. Now, what I've not gotten to, unfortunately, is to tell you how this informs our view of Google. However, my time is roughly speaking up. So thank you so much for letting me speak, and maybe we'll get to it at the end. We'll see.
Hello, everyone. My name is John Taladay. I'm a partner at Baker Botts in the Washington, D.C. office. And I thought I would share a few reactions today. And I thought I would mention a few things I really liked about the paper, a few questions I thought it raised, provoked, I guess, in my mind that might take the study further. And then a few things that I didn't so much agree with at the end of the day. So first of all, I thought this paper was a really, truly valuable contribution to the scholarship on dominant firm behavior, especially and particularly because it does look at innovation effects for dominant firms. And I thought that was a little bit unique. And it does it in a very technical way, which you don't often see in the legal scholarship. And so I think it's also an endorsement for the inclusion of technologists in thinking about these problems, especially in our digital universe. So it was very well done. Secondly, I think especially the historical analysis of AT&T, that case I thought was not only fascinating, but incredibly in-depth. The first 6 years of my career, my boss was the DOJ lawyer who tried the AT&T case for 200 and some days, he would frequently tell me, before it settled, before the consent decree was issued. So I heard a lot about AT&T, but I learned a lot more by reading this paper. And so it's really, if you like history and if you like antitrust, this is the article for you. It also delves into the brinksmanship of AT&T in protecting its monopoly in a way that I thought was really fascinating and informative about some of the tricks and games that you might expect a monopolist to play. Now, the key takeaway here is that innovation incentives of dominant firms are likely to be subdued to the extent that they undermine the current market position of the monopolist or that they cannibalize existing revenues. That may not be such a shocking revelation. I think we heard Commissioner Meter mention that earlier today. But I do think the article helps to unwind when those conditions exist and the mechanisms that are used to sort of withhold innovation to accomplish those goals in those circumstances. So I really commend you for that. I think those were all really outstanding contributions, as I mentioned. As I read through it, it caused me to think, I wonder about this and that. And here are some of the this and that's that came to mind. So first of all, the article somewhat presumes that dominant firms either possess transformative innovation or that they have the ability to develop that kind of transformative innovation, largely based on their installed base of assets. And it uses that presumption to conclude that challenging monopolies will have the salutary effects of releasing captured innovation. But I think that presumption could be strained in some ways because a lot of dominant firms are sort of one-hit wonders, right? I mean, BlackBerry was dominant at one time. It's kind of the My Sharona of the cellular handset world. People loved it. They kept humming that tune for a long time, kept waiting for the next one, but it never came along. And eventually something else did. There are other examples, I think Xerox, Kodak, of companies that were dominant at one time that just didn't have a second act. So I think that, excuse me. So I wondered whether more work could be done to look at when you might be able to predict that dominant firms actually have that ability and when they don't, because it's not clear to me that they always do. So that's an area of further inquiry that I thought might be useful. The paper, as you mentioned, focused on 3 instances of transformative technology, but it didn't address the issue of what I would call innovation cycles or iterations of technology within the dominant market. And there are a lot of industries in which that's very important. When do you release your next chip? When do you release your next 12-dimension television set? Those kinds of questions, I think, come up a lot because there are gradations of innovation. So for example, should Microsoft release a new version of Windows every time they have a tweak that might make it easier to navigate or integrate the products within the suite? So it seemed to me that if you're going to say, all right, we have some innovation to unleash, there needs to be at least some threshold at which you can determine it's sufficient enough to call it, transformative. And figuring out where that line is drawn, I think, would be useful because I do think there's clearly some sort of gradation there. And then the principle that withholding technology doesn't seem to be limited to dominant firms, although I do think they have different incentives to do it, right? But if you think about the fact that a non-dominant firm might have an innovative technology and decide for strategic reasons, we don't want to release this yet, we want to wait for something else to happen, right? And if you accept that as a true principle, then I think you have to also accept that the same might apply to the dominant firm, that there might be not anti-competitive reasons for them to strategically decide to withhold an innovation for a different time, for compatibility reasons, wherever it might be. And I thought that more analysis, and by the way, I'm not criticizing the paper for not having the analysis. These are just additional questions that got raised in my mind.
I'm a scientist. This is nothing. We're good.
Okay. We're not done yet. Thinking about how you differentiate between what might be competitive strategies and anti-competitive strategies for withholding innovation and comparing dominant and non-dominant firms would be an interesting thing to do. Now, there were a few things that I just couldn't buy into. First of all, from an antitrust standpoint, the article really doesn't draw a connection between the withholding of the innovation and the illegal anti-competitive conduct. It does talk in some past cases about tying, but it doesn't establish that the withholding of the innovation itself is somehow anti-competitive. And while I think the paper looks intensively at the innovation path of the technology, it doesn't really make the case that withholding that technology is anti-competitive or exclusionary. And I think it's a step too far to say that the mere fact of withholding that technology is anti-competitive. Because if you go that far, you're really basically dismissing the idea of property rights. If people have the ability to develop something, they have the right to decide when to release it and how to release it. And I think saying, well, we know that they're dominant and we know that they have this innovative technology, the fact that they haven't released it is anti-competitive, I think goes too far. And I do think the paper sort of pushes hard in that direction. It also argues that the monopolist, when it releases innovation, will tie it to the existing monopoly product as an exclusionary tactic. And there's not a lot of discussion about that outside of the IBM case. But I think it ignores the question, which I think is an important one, of whether that innovation has potential synergies with the existing product. Because if you develop the innovation and you think that it has even a scintilla of synergy, why wouldn't you want to capture that synergy as a developer of that product? Why wouldn't you want to integrate them and develop a synergy? Now, if there are no synergies or counter synergies to doing it, then clearly you would be able to say that's exclusionary and competitive. But I think just the withholding of it itself, or the tying of the product to the monopoly product, I don't know that you could presume that that's somehow exclusionary. But lastly, the narrative that somehow this captured innovation justifies regulatory intervention, and I do think that's the term that was used, regulatory intervention, goes too far. So the sentence that really got me, it says, the refusal of a dominant firm to deploy the innovation it generates is just as much a harm to the marketplace as is raising the price of the goods they sell. Well, neither one of those things is actually anti-competitive. And so I do get the point that, well, if you do challenge a monopoly, if you break up the monopoly, you might have this salutary benefit. I don't think the end justifies the means, and that was the biggest problem I had with the article. But I do want to say it was excellent. I enjoyed it, and thank you for writing it.
Can I respond super quickly? So thank you so much. That's really useful, and I think in particular I appreciated your push toward more quantification. I think the one thing I would slightly push back on is it was not our goal to say that this was always anti-competitive. To be clear, I think this is, and I think some of this is the fact that I'm not a lawyer, nor do I aspire to be, and to me, I think the most interesting thing about this historical pattern is what it tells us about innovation for those of us who just want to see innovation move forward. And I think you're right that this is not always anti-competitive. And I think my goal with this paper was to try to understand when this happened, when antitrust enforcement actions had this effect, why was it happening? And I think it's important to know that because I think that, we're staring down the barrel of a whole bunch of antitrust enforcement actions against big technology companies, and we're going to have to figure out what remedies in those cases are going to look like. And I think when law enforcers understand, historically speaking, what has led to really good outcomes for markets and consumers in the past, that it's dynamics like these that have factored in. And I think that was more our goal, rather than to say, if you see a big technology monopoly, then that is not deploying things, that it is always anti-competitive. So I just wanted to sort of say that is not the position we're trying to take in the paper.
Well, thank you very much. You certainly deserve the last word, and thank you again for the paper.